Okay, module number 16 has fewer topics because we're at the end of a unit. So I think there's only 10 in here, but let's go ahead and get started. The first one will be graphing a rational function, specifically quadratic over linear. Okay, so that means that we're going to have an x squared in it. Linear means we'll have an x in it. Okay, and so there's a few things that we need to do. The first thing we need is any vertical asymptotes. And in this case, since it's linear, there would only be one. What value of x makes the denominator 0? Okay. The second thing we need to do is find your slant asymptote. And that will be, since the degree of the numerator is larger than the denominator, we'll have to do division. Okay, and all of these graphs will have two branches to them. You'll see, if you're not sure what that means, you'll see when I start to draw it. 2 points on each branch. And the easiest way to do that will be to kind of start close to the asymptote. Okay, so let's get an example here. Underline my topic there. Okay, so our example here is f of x is negative x squared minus 2x plus 4 over x plus 1. Okay, so first of all, our vertical asymptote, when x plus 1, so your denominator is 0, that would mean x equals negative 1. So that's it. That's the equation of a line. X equals negative 1 is a vertical asymptote. Okay. Our slant asymptote, we actually need to do the division. So x plus 1 times what is going to get us to negative x squared minus 2x plus 4. Okay, so we need a negative x squared, which would mean we need a negative x here. Oops, not squared, just x. Okay. I'm going to apologize like I do in like every video that my Chromebook is not working very well. Okay, and then a negative x here. We're trying to get to negative 2x, so we need another negative x, which means a negative 1 here. Okay, and then that will put a 1 here. Your remainder would be 3, but remember when we're finding these slant asymptotes, we don't really even care about the remainder. So your asymptote would just be y equals negative x minus 1. Okay. Now we can start your sketch. Okay. So 1 asymptote at x equals negative 1. Come on. Okay, so there would be x equals negative 1. And our slant asymptote would be a line. The y-intercept is negative 1. And the slope is negative 1. So okay, there's y equals negative x minus 1. Okay, now the two branches, they're either going to be here and here, or here and here. Okay, and now by plotting our points, we'll be able to figure that out. Let me erase those for now. Okay, so like I was saying before, stick close to your asymptotes. Okay, so x equals 1. And let me rewrite the equation here. F of x is negative x squared minus 2x plus 4 over x plus 1. Okay, so we know that if I plug in, and it should be negative 1. If I plug negative 1 in, I'm going to get undefined, which is why it says an asymptote. So just move out from negative 1. Okay, so like if we make a table here, negative 1, we're undefined. Okay, so maybe then we'll do negative 2 and negative 3, and then 0 and 1 for our points. Okay, so you got to take some time to do this. 0 is obviously going to be easy. F of 0 will be, in the numerator, be 4 over 1. So 0, 4. Okay, so I can plot a point at 0, 4. If I plug in 1, let's see, I'll have negative 1 minus 2 plus 4 over 2. So it'd be 1/2. Okay, so 1/1/2 could be another point. All right, and then I can do negative 2. I'm going to go up here so I don't have to scroll down. F of negative 2, so it'd be negative 4, okay, because negative 2 squared is 4. Then I make it negative, minus 2 times negative 2, so plus 4, and then plus 4, over negative 2 plus 1, so negative 1. So that would be negative 4. Okay, so negative 2, negative 4. And then my last one, I'll do f of negative 3. So that would be negative 9 plus 6 plus 4 over negative 3 plus 1, so negative 2. So negative 9 plus 7 would be negative 2 over negative 2, which is, well, I messed up somewhere, didn't I? 9. Oh, I put a 1 there instead of a 4. So that should be a positive 1 and a negative 1/2. Okay. And I would have caught that, maybe. Because what did I have? I had negative 3, positive 1. I guess that is a possibility. Okay, negative 4, negative 1/2. Okay, so I can see, oops, why did I write 4? Negative 3, negative 1/2. Got all thrown off there. Okay, and then Alex you click on the draw function and it'll do it, but it should look like that and that. Okay, so that's it. All right, let's do another one. The next topic is, let me scroll up here. Next topic is matching graphs with rational functions. To vertical asymptotes. Okay. So what we want to do for this is, I'm just looking at the example that they give you. Okay. They'll give you an example. So I got a lot to draw here. Okay. So they give you f of x is 2x minus 2 over x squared minus 9. And then they give you g of x is 4 over x squared plus 2x minus 3. Okay. And I think you can definitely find your two asymptotes. And then from there, you can use numbers to plug in. Let me see. I'm just looking at Yeah, you can kind of just plug in some numbers to see, so you can kind of eliminate one. Yeah, okay. So graph A, they have, let me just do graph B, graph C, and they have graph D, oops, graph E, and graph F. Okay, so graph A. Oh boy. Come on. Okay, graph A has an asymptote at x equals -3, x equals 1 along the x-axis. And then it has a function that goes like this, this, and this. Okay, graph B is similar, still at -3 and 1. We have a horizontal one up at, looks like 3 to me. Okay, and then the branches on this one, here, here, and here. Okay, graph C, -3, +3, the x-axis, and here goes like this, this, and this. Okay, and then we have graph D, which gives you -3 and 3 also. And the x-axis. And this one kind of has like a little wonky off-center thing to it. And then here and here. E, we got -3 and 3. And the x-axis. Let's see, this one didn't go there. Come on. Okay. E is similar to C, but it goes this way instead. Okay, and then F, we've got -3 and 1. Excuse me. The x-axis. And it's kind of like graph A, but it's upside down. Okay. All right. So there's all the graphs. Okay. So the first thing that you want to do with these functions is find their asymptotes. So f of x, we're actually going to factor it. We're going to do 2 times x minus 1 in the top, your GCF factoring. Difference of squares factoring in the bottom. X plus 3, x minus 3. Okay. For g of x, we've got 4 over, factor the bottom, that'd be x plus 3, x minus 1. Okay. So graph, or f of x has asymptotes at x equals -3 and x equals 3. And g has x equals -3 and x equals 1. Okay, so for g of x, I'm going to kind of color code a little different here. F of x, the possibilities are possibly c, D, and E. Those are all the ones that have the asymptotes at -3 and 3. Okay. And then G could be possibly use blue here for G. G could be the ones that have the asymptotes at -3 and 1. So G, G, and then this one could possibly be G. Okay. Now, the next thing we do is we figure out your horizontal asymptotes or your slant asymptotes, your end behavior asymptotes. So since both of these, the degree of the numerator is less than the denominator, let me get green here. So for both, the horizontal asymptote is at y = 0, the x-axis. Okay. Again, remember, if the degree of the numerator is less than the denominator, the x-axis is your asymptote. Okay. So we can rule out graph B for anything then. Okay. Now, the next thing that you're going to do is you're going to plug in some points. Okay. So the easiest thing to do is find 0. So f of 0, right, would be 2/9. Okay, so if you look at your graphs, and I'm looking on Alex too, because they're a little bit more accurate, the 3 that I chose that could possibly be F, graph C, it does look like this little branch is a little bit higher, so that could be at 2/9. Okay, graph D, it's definitely higher than 2/9. This is 1. Okay, so we can eliminate graph D. All right, and then graph E, this is a little bit lower than 2/9. Okay, so that could not be graph F either. So definitely C is graph F. Okay, f of x. So let me just double check my answer here. Yeah, okay. All right, so we figured that one out. Now we look at G, and we're only down to 2 for G, and you can already tell that if I figure out the y-intercept, I'll know which one it is, right? Because one of them's positive, one of them's negative. So then G of 0 will be 4 over -3. So -4/3. And if you look, graph A could possibly be at -4/3, but graph F, that y-intercept is positive, so it's not graph F. Okay, so G would be graph A. So it's kind of a process there, process of elimination. Definitely starting with your asymptotes and then plugging in some numbers. If we had not gotten it, with the 0, then maybe the next step would have been to plug in like f of 1 or f of -1, okay, to get some more points until you have enough points to figure out which graph it is, all right? Okay, let's move on to the next topic. Which is graphing a rational function with more than one vertical asymptote. So like the ones that we just saw. Okay. So let me just see how much of it they want you to do on Alex. So they give you a function, -10x plus 20 over x squared minus 3x minus 10. They want you to do a few things here. They want you to draw the vertical asymptote, plural. They're already telling you there'll be more than one. They want the horizontal asymptote. Asymptote. And there will only be one of those. Okay. They want the intercepts. that's also plural. So your x-intercept and your y-intercepts, or there could be more than one x, not more than one y. And then 1 point on each side of each vertical asymptote, okay? Okay. So again, to find your vertical asymptotes, that's going to be what makes the denominator 0. Okay. Your horizontal asymptote, again, we did that in module 15, so it depends on the degrees. So if you remember, if the degree of the numerator is bigger than the denominator, you would divide to find a slant asymptote. They're kind of already telling you that it's going to be a horizontal asymptote, so that we probably won't be doing that in any of these. If the degree is the same, remember you look at your leading terms. And if the degree of the numerator is less than the denominator, it's just going to be the x-axis. Okay? Your intercepts, when x equals 0, and then, not at the same time, y equals 0. Okay, and then points you're just going to plug in for your equation. So the first thing you're going to want to do is factor the numerator and the denominator, just like we did in the previous problem. So I can take out a GCF of 10, or even negative 10 if you want. And a lot of times we like that x to be positive. It doesn't matter. I could factor out a 10, and then I'd have negative x plus 2. I'm going to factor out a negative 10, so I'll have x minus 2. Okay. And then the denominator, let's see, that would be x minus 5, x plus 2. Okay. Or, like I was saying, if you just factor out a 10, then you have negative x plus 2 over x minus 5, x plus 2. Doesn't matter. Okay. All right, your vertical asymptotes would be what would make the denominator 0. So that would be your zero product property if either of those factors are 0. So x minus 5 would equal 0 if x equals 5. And x plus 2 would equal 0 if x equals negative 2. Okay, so there's your two vertical asymptotes. Your horizontal asymptote, since the degree of the numerator is less than the denominator, you will have the x-axis. Okay, so there's your three asymptotes. Okay, and then we can also jump right ahead to the intercepts. Okay, if x equals 0, f of 0 would be 20 over negative 10, which is negative 2. So 0, negative 2 would be one intercept. Okay. If y equals 0, so that one's a little trickier. Think about that. If 0 is negative 10x plus 20 over x squared minus 3x minus 10, all that we would have to have happen is the numerator is 0. Okay, so your y-intercept is whatever makes the numerator 0. Okay, so negative 10x plus 20 will equal 0 if x equals 2. Okay, and we could even go back to where we had it in factored form. Okay, if x minus 2 is 0, or if negative x plus 2 is 0, that's when x is 2. So 2, 0 is another intercept. Okay, so again, for that y-intercept, just figure out what would make the numerator 0. Okay, if there's a constant, if it's like our previous one where we had 4 in the numerator, then there is no y-intercept. I'm sorry, no x-intercept. Okay, so if you look here at that graph there, right, we didn't intercept the x-axis at all. Okay, we had the y-intercept, all right, that negative 4/3, but there is no x-intercept. Nothing could make that numerator 0 because it's always 4. Okay. All right, so we can start drawing here. Come on. Okay. Whew. Let's go yellow. Your asymptote at x equals 5. Your asymptote at x equals -2. Your asymptote at the x-axis. Okay. Your intercept at 0, -2. And then we also have an intercept at 2, 0. Okay. Now we're going to want to find some more points. Okay. That's not enough for us to get us a good graph here. So we need to kind of know what else is going on. So we can, let's see, we know that we have to approach the asymptote. So, we know that we'll like connect these two, but then the question is, is this doing something? Let me scroll back up. Okay, is it going to do something like this in the middle, or is it going to do something like this in the middle? Okay, and then also our side branches, we don't know. Here, that's what. Okay, so in yellow, I circled the two possible things that could be going on in the middle. The side branches, we kind of know that they're going to be like those L shapes, but are they going to be here and here? Or are they going to be here and here? Or maybe they're going to be like on the same sides like that. Okay, so we're just going to get some more points. All right, so let me scroll back down. All right, so I would do, let's see here. So I would do one value to the left and right of each asymptote. So I would want to do f of -3, f of -1, f of 4, and f of 6. Okay, one to the left and right of each asymptote. So f of -3 is going to be, let's see here, and I'm going to, okay, so it'd be the negative, yeah, you know what? Do I want to leave it in factored form? I don't. Okay, so I'm gonna rewrite my equation down here so I don't have to keep scrolling. -10x plus 20 over x squared minus 3x minus 10. Okay, so come on, Chromebook. All right, so f of -3, I'd have 30 plus 20 over 9 plus 9 minus 10. Okay, so I would have 50 over 18 minus 10, which is 8. 50 over 8. Okay, let's see, that's 25 fourths. So 6.25? 6.25. Okay, so f of -3 is 6.25. Okay, so then that's pretty clear what's going on there. Okay, all right. F of -1, let's see, I'd have 10 plus 20 over 1 plus 3 minus 10. So 30 over -6, which would be -5. So -1, -5. It's maybe right around there. Okay, which we kind of suspected that would happen. What we're unsure of is what's going on after that. Are we coming back down after x equals 2, or is it going back up or continuing up? Okay, so f of 4 is going to tell us that. So f of 4 would be -40 plus 20 over 16 minus 12 minus 10. So -20 over -6. Okay, which would be 10 thirds, so 3 1/3. So 4, 3 1/3. So now we can see what's going on. It's looking like that. Okay. And then our final one would be f of 6. So negative 60 plus 20 over 36 minus 18 minus 10. So negative 40 over 36 minus 18 would be 18. 18 minus 10 would be 8. So that's going to be negative 5. So we'll be at 6, negative 5. Okay, so kind of like that, and boom. Okay, so there's our graph. All right, a lot of steps, but nothing super tricky, right? We just had to find 4 different points, and that took some time, but it's not like it's difficult calculating to do. Okay, so just remember the 4 things you need to find. Make sure you've done all those. Okay, all right, let's take a look at the next one. We have writing the equation in here. Writing the equation of a rational function given its graph. Okay, so this one's got kind of a lot going on too. It says the figure below shows the graph of a rational function f. It has vertical, well here, let me draw up a function here. Come on. So we've got an asymptote at negative 5. And another one at 6. And then it says that we have a horizontal one at y equals negative 3. And then it says we have x-intercepts at negative 1 and 3. And it passes through the point negative 3, 2. Make the point there. Okay, and then we've got our graph. Come on. That, and that. Okay, pretend it goes through the points it's supposed to go through. Okay, now they give you some choices. And this is where it's going to look really tough. I'm not sure that I'm a fan of this topic here. Okay, so they give you, is it in the form f of x equals a over x minus b, f of x equals a times x minus b over x minus c? Is it in the form f of x equals a over x minus b, x minus c? Come on, scroll down. There we go. F of x equals a times x minus b over x minus c times x minus d, or hopefully they're only giving us one more Or is it f of x equals a times x minus b times x minus c over x minus d times x minus e? So you have to figure out the form first, and then you have to figure out what the values of a, b, c, d, or e are. Okay, so before you pick out the form, all right, there's a couple of things to note here. So first of all, the fact that it has two x-intercepts, okay, means that, the fact that it has a y-intercept means that there's something that would make the numerator 0. Okay, so the numerator is not a constant. So we can get rid of that one. Okay, so it has to be x minus b in the numerator. Okay, it also means we can get rid of this one. Okay, wait, did I just mix that up? Yeah, there's two of them. I'm sorry. Y would be 0. I'm sorry. Okay. There are two x-intercepts, right? X equals -1. And x equals 3. So again, if we go back up here, remember, y equals 0 when the numerator equals 0. And in this problem, there was one thing that made y equals 0. It was when x was 2. And so we had one x-intercept. Okay, and it was right here. Come on. Jeez. Come on. Give me a second here. Okay. Okay, so it was right here. All right, so we have two x-intercepts in this one. Okay, and so we know that we have to have, in our numerator, we need an x plus 1 and an x minus 3 to get those two x-intercepts. Okay, the other thing we know is that we have the two vertical asymptotes at x equals -5 and x equals 6. So we know that in our denominator, we have to have x plus 5 and x minus 6. Okay, so there's most of the work. All right, we have figured out that it's definitely this last form here. Okay, and we have already shown what B, C, D, and E are. All right, it doesn't really matter which one is which. You just type in, I think they just have you type in your equation. Okay, so we don't have to write like B equals C equals D equals. We're going to write in something like this. Okay, so the last thing is to figure out what A is. And to figure out what A is, we use that extra point that they gave you. All right, we've used all of the information they gave us, right? That we've used the two x-intercepts, the two asymptotes. One thing that we haven't used, actually, I should say, is that we haven't used the fact that the asymptote is at y equals -3. Okay, so that tells us, remember, if the asymptote is not the x-axis, when the degree of the numerator and the denominator are the same, it's the ratio, right, of the leading terms. If I were to expand the numerator out, I would have an x squared. If I were to expand the denominator out, I would have an x squared. So it's the same degree, which means the ratio of the leading terms, right? We'd have a times x squared plus some junk here, and then we have x squared plus some junk here. Give me a second for that to show up. Okay, so the ratio of the leading terms gives us that horizontal asymptote. It's got to be -3. Okay, so A has to equal -3. Okay. The other way that you can solve for A, which you might have to do in some of the other ones where it's not the same degree, okay, so it was like a problem like that, is you use the other point that they gave you. So the fact that the point -3, 2 is on the function, okay, so what we could do then is plug 2 in for y, and then -3 in for x. And then we can solve for a. So 2 would equal a times -2 times -6 over -2, come on, times -9. Did I just do that right? So y is 2, x is -3. Oh, that'd be positive 2. Okay. So 2 would be 12a over -18. Okay, so cross multiply, -36 would equal 12a. So a would be -3. Okay, so there's another way you can solve for a. And like I said, you're probably going to have to do that if it's a problem like that, because the ratio of the leading terms isn't what you use in that one, right? We know that if it looks like that, the asymptote's going to be at 0 because the degree of the numerator is less than the denominator. So for something like that, you're going to have to solve for a by using the extra point that they give you. Okay? All right. Next one. We have solving a quadratic inequality written in factored form. I remember doing these in Algebra 2, so maybe these will come back to you a little bit more. Okay, so in this one we have x minus 3, x plus 2 is greater than 0. Okay, and they've already factored it for you, which if they hadn't, your first step when you did these in Algebra 2 was factoring. Okay, if you remember from Algebra 2, we made a number line, and we found what was called the boundary points. Okay, we found what would actually make this expression equal 0. Okay, so x minus 3 times x plus 2 equals 0 using your zero product property if x is 3 or if x is -2. Okay, so, and if you remember too, we didn't really care about the scale here. We just cared that -2 was less than 3. Okay, and then you tested points. Okay, you tested a point in each of those regions. So we would test, and usually you didn't want to come up with anything too crazy, but you could. Like we could test x equals -10. You always want to test 0 if that's in the region, right? Between -2 and 3, we'd want to hit 0 there. That's always going to be an easy one to plug in. And then maybe do like x equals 10. Okay. And then you test the points. So if x is -10, I would have -13 times -8. Right? If I plug it back into my equation, -10 minus 3 is -13, -10 plus 2 is -8. That's a positive number. I don't even care what positive number it is. I just care that it's positive. Okay. When I plug in 0, I'm going to have -3 times 2, which is -6. And again, all I care is that it's negative. Okay. And then x equals 10. 10 minus 3 is 7. 10 plus 2 is 12. Positive times a positive, that's going to be positive. Okay. I'm looking for where this expression is greater than 0. Okay, so I'm going to shade in where it's positive. Okay, and then you have to ask yourself if you're going to shade in the points or not. Since it's just greater than, not equals to, we're going to leave them as open points. Okay, so there is your solution on your number line. If they ask you to write the inequality, I don't know that they're going to. Let me check the answer here. Yeah, they just have you graph these on a number line, so you don't have to worry about writing the answer. It would be x is less than -2, or x is greater than 3. Okay, but these solutions for this particular one, they just want the number line. All right, so again, just find your zeros, which are called your boundary points, test within each interval, and then shade appropriately, and make sure you double check if you're supposed to have open circles or closed. Okay. All right, that one was a little bit of an easier one after all those weird graphs, right? I do like the graph ones because they can kind of teach you some logic there, but they take a lot of time. Okay. Now we have solving a quadratic inequality, similar to what we just did. Graph the solution to the following inequality on the number line. Okay, so, and I spelled quadratic wrong. Okay. So it's just what we just did, but you have the added steps. Like they gave that to you in a nice factored form. We got to get there. Okay, so they're going to give you something like x squared minus 8x is less than -12. Okay, just like if that's an equal sign, we have to get everything to one side. And then we would factor it. Okay, so this one would be an x minus 6, x minus 2. And now it's just like the previous problem, right? We're going to take our number line. Our boundaries would be x equals 2 and x equals 6. And then we're going to test a point. Okay. And again, if you can test 0, that's usually an easier one to test. Okay. Otherwise, maybe we'll take 5s. I don't know. And don't be afraid. I mean, x equals 100. Doesn't matter. Okay. You just got to test points now. So if x is 0, I would have -6 times -2, which is positive. Okay. If x is 5, 5 minus 6 is -1. 5 minus 2 is 3. So that would be negative. Negative times a positive, right? Okay. If x is 100, I have 94 times 98. That's going to be a positive number. Okay. I'm looking for where we're less than 0. So I want to shade from 2 to 6. And then I also need to ask myself, do I, come on, shade, open circles are closed? Since it's less than, not less than or equal to, I'm going to leave them as open circles. And that graph is my final answer then. Okay. All right. We have another one now, solving a rational inequality. I think you did these in Algebra 2. It's a similar idea. Okay. Solving a rational inequality. And they call this problem type 1, whatever that means. It's a similar process. Okay, in this case, we have -x plus 6 over x plus 2 is less than 0. Okay, your boundaries are still what would make each piece equal to 0. X equals 6 would make the numerator 0. That's where your y-intercept is. X equals -2 would make the denominator 0. That's where you would have a vertical asymptote, okay? But those are the two places where something like this could possibly switch signs, okay? So same idea. What makes the numerator 0? What makes the denominator 0? Draw a number line. And this is one too where maybe when you're done, you go ahead and graph it. So you kind of develop that number sense, right? That graph sense, I guess I should say. Okay. We do see that it's less than, not less than or equal to, so I'm just going to put the open circles on right away. Okay, and then same thing. You're going to test some points. So maybe I test at x equals -10, x equals 0, and x equals 10. Okay, if x is negative 10, then I have negative negative 10, so be careful with that. It'd be 10 plus 6, so 16 over negative 10 plus 2, which is negative 8. So that's negative. Okay, and then from negative 2 to 6, if x is 0, I have 6 over 2, which is positive. Okay, and then at 10, I'd have negative 10 plus 6, which is negative 4, over 10 plus 2, which is 12. So that's going to be negative. In all of the examples we've done, it has alternated, like positive, negative, positive. It doesn't always happen, especially with these rational ones. So don't always just assume that. You got to check them all. So just be careful with that. And honestly, the quadratic ones, it will. But for the rational ones, not necessarily. Be careful. Okay, but I think you'll probably see that a lot. All right. But anyways, this one, they want you to write it in interval notation. They don't want, it's not just the number line. So we would go, we're looking where it's negative, right? Where it's less than 0. So negative infinity to negative 2, not including. Okay. They want you to use the union sign to link your intervals. And then again, from 6, not including 6, to infinity. Okay, and remember, if it was less than or equal to, and we were supposed to include those boundary points, we would do square brackets on the negative 2 and the 6. Okay, never square brackets on the infinities, though. All right, there we go. Okay, let's move on to the next one. All right. We got 3 left. Okay, oh, this one's good. Not too shabby for this next one. Okay, the next one is classifying the graph of a function. Okay, so for this one, they give you functions, obviously. Okay, this froze up a little bit here. Let me get, come on, we only have a few more topics left. Don't freeze up on me now. Wow, it's really not letting me go any further. Okay, it could be a vertical line. It could be a horizontal line. It could be a line with a negative slope. It could be a line with a positive slope. It could be a parabola opening down. And it could be a parabola that opens up. Okay. I cannot scroll down any farther than I already am. So, oh, no, just let me a little bit. Okay, anyways, a vertical line. So this is not written in for you, and I'm going to write it for you. A vertical line, remember, that will be straight up and down, so that's an x equals. A horizontal line would be a y equals. Okay, line with a negative slope would be y equals mx plus b, where m is less than 0. Line with a positive slope would be the same thing, but m is greater than 0. Parabola that opens down would have a negative x squared in it, and a parabola that opens up would have a positive x squared in it. Okay, so just like a line with a negative slope would have a negative x in it, a line with a positive slope would have a positive x in it. Okay, so the ones that they give you in this one, let's see, they give us h of x is 3x squared minus 4x. G of x is x plus 3, and f of x is 1. All right, so these should be pretty straightforward. H of x, we have an x squared in it with a positive coefficient. That's a parabola that opens up. Okay, g of x, that's line, right? X y equals mx plus b. X is positive, so we have a line with a positive slope. And f of x equals 1. Remember, f of x is just the same as saying y equals 1. So that's a horizontal line. Okay, and that's it for those. Come on, check mark. There we go. Okay, so I think that I need to stop the video because this is not letting me scroll. Oh, let me scroll up but not down. Okay, so I'm going to, you know what? I'm just going to export this drawing. Okay, and I'm just going to do a new drawing. See if it'll let me do that. Nope, you can see on my to-do list there. My drawings from my kids. Maybe you can't see that if it's not sharing. Okay. Let me just double check that I'm recording. Yes. Okay, let's try to get these last two topics in without having to do a new video. The next one is, I think you've seen this before. Okay, maybe not. Dividing a polynomial by a monomial multivariate. Okay, and I'm just gonna, let me just see real quick here. These are they make them sound really scary, but they're not awful. Oh yeah, these aren't bad at all. Okay. It's not something that is typically not very much. Okay, let's do this one. Okay, so this one we want to divide negative 11 u to the 6 x to the 7 plus 8 u to the 6 x. And then divided by negative 4 u to the 5th x cubed. So it looks super complicated. It's not bad. Okay. So what you have to do is keep in mind that this would be negative 11 u to the 6 x to the 7 plus 8 u to the 6 x over negative 4 u to the 5th x cubed. Okay. And then also the fact that we can split numerators. So we can write this as negative 11 u to the 6 x to the 7 over negative 4 u to the 5th x cubed plus, because there's a plus here, 8 u to the 6th x over negative 4 u to the 5th x cubed. And then we just simplify. Okay, so like this first one, the negatives cancel out, so we can have 11 over 4. We have a u to the 6th over u to the 5th, so that's just u. And an x to the 7th over x cubed, so that's just x to the 4th. And then for our second one, we have 8 over negative 4. So 8 divided by negative 4, that's just negative 2. U to the 6 over u to the 5th is just u. And then x over x cubed leaves you an x squared in the denominator. And that's literally, that's it. That's the answer. You're right. It is the sum of two rational expressions like that. So 11u x to the 4th over 4 minus 2u over x squared, or you can write it as plus negative 2u over x squared. Okay. All right, we got one more topic here. Graphing rational functions with holes. I was wondering if they were, oh, look at that. It's not letting me scroll again. Okay, that's okay. We're going to finish this up. Graphing rational functions with holes. Okay, so we were looking at rational functions before. And if you remember, you figured out what makes the numerator 0 to find your x-intercepts. and then what makes the denominator 0 to find your vertical asymptotes. Okay, but now the question comes up, what happens if the same number makes them both 0? Is it an x-intercept or is it a vertical asymptote? And the answer is it's neither, it's a whole. Okay, so we'll take a look at a graph like this. We have h of x is negative 2x plus 6 over x squared minus 4x plus 3. So if you think back to when we had graphing rational expressions with two vertical asymptotes, okay, this looks like a problem right out of there. Okay, so we would figure out, okay, your vertical asymptotes, again, whatever makes the denominator 0, the denominator I can factor to be x minus 3, x minus 1. So x equals 3 and x equals 1. Okay, I could get my horizontal asymptote. Okay, the degree of the numerator is less than the denominator, such as your x-axis, so y equals 0. Okay, my y-intercept, if I make x equals 0, I would have 6 over 3, so it would be 0, 2. Okay, and then my x-intercept, whatever makes the numerator 0, so negative 2x plus 6 equals 0, 2x equals 6, x equals 3. Okay, and that's where we run into an issue, is when I start to graph this, right? I've got my vertical asymptotes at x equals 1 and x equals 3. I have my horizontal asymptote at y equals 0. I have my y-intercept at 0, 2. And then I have my x-intercept at 3, 0. And that can't happen. Okay, I cannot have an x-intercept in the same spot that I have a vertical asymptote. Okay, so what happens then is, and again, the reason I didn't see that right away is because I didn't factor this. So if I factor out the negative 2, I'm left with x minus 3. Okay, so these things can't both happen. Okay, so what this means then is basically I go through the same process. There is no x-intercept. There is no vertical asymptote at x equals 3. Okay, it's what we call a hole in the graph. There's a hole at when x equals 3. Okay, here I'm just going to do. Okay, so when I sketch this, and I'm going to show you in a second how you find the coordinate, the y coordinate. Okay, I still have my vertical asymptote at x equals 1. I still have my horizontal asymptote at y equals 0. I still have my y-intercept at 0, 2. Okay, but now I have a hole when x is 3. Okay, and then what I do is I take this, and this is negative 2 over x minus 1. Okay, and I plug that 3 into what I have left. Okay, so I don't want to say, this would not be true. H of x is not the same as this. It's the same as this if x is not 3. Okay, so everything about this graph will look identical to the graph of negative 2 over x minus 3. Go ahead, graph them both. Get out your graphing calculator, graph this, graph negative 2 over x minus 1. They look like the same graph. Okay, but the difference is if you look in your table when x is 3, or if you try to trace your graph to x equals 3, in that second or in that first one, it's not going to have a point. Okay, and the second one, negative 2 over 3 minus 1 is negative 2 over 2, which is negative 1. So it has a hole at 3, negative 1. So 1, 2, 3, negative 1. Okay, and again, this is, since we have two intersecting asymptotes, we have two branches, and we have already figured out where the two branches are, right? One of them has to go here, and then one of them would go here. Okay, and then that is it, and I believe that is it for Module 16 as well, and that is it for your Chapter 3 material. Yep, okay.